Hi everyone, this is Peschu. Welcome to my channel. Today we are going to talk about the price elasticity of demand, and what we are going to do is define the term, look at the formula to calculate the price elasticity of demand, and then talk about the values of price elasticity of demand and the range that these values can take. Okay, so let's get started. First of all, let's start by defining price elasticity of demand. And price elasticity of demand is a measurement of the responsiveness of quantity demanded with respect to a change in the price. I did a video on how to derive the definitions and the formulas for the elasticity concepts in general, but since price elasticity of demand can be written like that, so it will be, like I said, responsiveness of quantity demanded with respect to a change in the price. In other words, how much will quantity demanded change if we change the price by a certain percent? And we have a formula for that. The formula can be written as the percentage change in D divided by the percentage change in P. And we can expand this, and it will become as quantity demanded 2 minus quantity demanded 1 over quantity demanded 2. So this is your general percentage change formula times 100% divided by P2 minus P1. Oops, there should be a 1. Excuse me, let me fix this quickly. No, 1. I did the same mistake again. So QD2 minus QD1 divided by QD1, P2 minus P1 divided by P1 times 100%. Okay, this is the expanded formula. And a general rule would be the percentage change in the percentage change in y, whatever y is, would be equal to y2 minus y1 over y1 times 100. Now, you may see some variations of this formula, and again, it will be useful to consult your textbook or ask your teacher, because sometimes instead of dividing by the old value, some textbooks tell you to divide by the average of the two values, and that will give you the price elasticity of demand at the midpoint. But in the most simplistic scenario, we divide new value minus the old value divided by the old value. This is the formula for the percentage change. So when we do this, we'll get something, and this will be our price elasticity of demand. We can actually cancel out these things, and if we do that, we can also derive it as something like this: QD2 minus QD1 over QD1 times P1 over P2 minus P1. Doing basic algebra. But most of the time you will see this one as the expression to expand this version of the formula. All right. Well, let's see a real example with real numbers, and then we'll talk about the values and the ranges that PED can take. and say something like this. Say 100. 1000. Then let's say 60. And 1500. Okay, so let's say we have a situation like this, effectively 2 points. At A, we have that quantity demanded is equal to 1000, and the price would be equal to 100. And at B, quantity demanded would be equal to 1500, and the price is 60. Let's plug in these numbers in the formula and see what are we going to get. So expanding these equations, we get 1500 minus 1000 divided by 1000, and over here we have 60 minus 100 divided by 100. Right, so this will be equal to what's it, 500, 0.5, and over here we have minus 40 minus 0.4. So 0.5 divided by 0.4, and if my math, this will be really humiliating if I get this wrong. Hopefully this should equal to minus 1.25. Don't judge me if this is incorrect, but I think it is correct. Okay, now what's important is, first of all, this negative sign. The negative sign is an illustration that we have a negative relationship between the price and the quantity demanded, which was described in the law of demand. An increase in the price level, given that everything else is constant, would lead to a decrease in the quantity demanded. This is from where this negative sign comes. And price elasticity of demand is always negative in nature. It's because of the negative relationship between the quantity and the price. Just you need to get used to that. However, you would see it in positive. You would see it without the minus. Now, people generally use positive values to describe price elasticity of demand just to make life simpler, but that should not fool you. The value is always negative. When you calculate it, you should get a negative value. If you get a positive value, that may mean that A, you either did a mistake, which is more likely, or B, you're talking about some very specific good which does not obey the law of demand, such as Giffen goods or Veblen goods. Those type of goods would have positive price elasticity of demand. But in 99% of the cases, if you don't get a negative value, that means you have made a mistake. So watch out. And if you see the negative sign, don't worry, don't be alarmed. It's normal. That's what you should be getting. When I was teaching economics, I would generally write price elasticity of demand like this, PED, and then I would put it in absolute value, and then I would say is equal to 1.25. And this would automatically tell me that 1.25 generally is negative. I'm putting it in absolute value just to keep in, to remember that it's negative, but now I'm using it as a positive number and it's easier to compare. All right, now these values, they can take a certain range, and let's do that and see what the ranges are. Ranges of price elasticity of demand, and I'm gonna put this in absolute values, just again to use positive numbers because it makes life somewhat easier. Okay, so I'll build a table. Actually, this will be the range, and we'll have a name. So generally, the three most common cases are the value is between 0 and okay, so PED like this and 1. So this is a value between 0 and 1. And this is called inelastic price elasticity of demand. What this means is that the percentage change in the quantity demanded will be smaller than the percentage change in the price. The next one is that PED is equal to 1, and this is called unit elastic. So over here, the percentage change in the quantity demanded will be equal, but with the opposite sign, to the percentage change in the price. The third one is price elasticity of demand is greater than 1. And this is called elastic, or elastic PED. So in this case, the percentage change in the quantity demanded would be greater, but with the opposite sign, than the percentage change in the price. And we have two extremes. Let's squish them here. Okay. PED is equal to 0. This would be perfectly inelastic price elasticity of demand. So what this tells us is that no matter how much we change the price, the quantity demanded will always stay the same. Quantity demanded doesn't change here. And the last one, I'm going to write it here, guys, just because I'm running out of space. And the last one is price elasticity of demand is equal to infinity. So this is perfectly elastic price elasticity of demand. Price elasticity of demand is equal to infinity. This means that for the given price, we can sell as many units as we can. There's nothing stopping us. Now, these two cases, they're extreme scenarios. We rarely see them, though we may approach them. For example, insulin. Insulin is a life-saving medicine for diabetics, and that could have a perfectly inelastic demand. People who need it are willing to spend as much money as it needs. Still, we have laws that would generally set a limit to the price of such medicines, simply because it will be very inhuman to benefit radically from someone's disease or something like this. Each of these, they can have different demands, so to speak. Actually, I somewhat lied to you, and you'll see why. The demand or the price elasticity of demand of a good can actually change along the demand curve. And depending on which part of the demand curve we are at a given moment, the price elasticity of demand, the value of PED will be different. And we can, let's say this is our demand. And the reason why I'm drawing a line that reaches the Q and the P axis is precisely to show those two extreme cases of perfectly elastic and perfectly inelastic price elasticity of demand. Now, let's take this point here, and this will be the midpoint. Why do we know this is a midpoint? Simply because it splits the demand curve into two equal parts. At the midpoint, our price elasticity of demand would be equal to 1, and it will be unit elastic. In this upper section, the PED would be elastic, so this would be greater than 1. And this section, price elasticity of demand, would be inelastic, so it will be less than 1 and greater than 0. And our two extreme cases are over here, where price elasticity of demand will be approaching infinity. And this arrow sign means approaching. And over here, the price elasticity of demand would be approaching 0. You can actually, if you draw a demand curve and you take points along it where you're measuring the price elasticity of demand, let's say if you take points here and here, if you take points here, if you take points here, points here, because you always need 2 points to measure price elasticity of demand. So if you take points here and here, if you do an exercise like this, and you figure out the coordinates and you calculate these price elasticities of demand, you will notice that these values will be close to 0, these values will be between 0 and 1, these values will be close to 1, these values here would be greater than 1, and over here you will be getting price elasticity of demand, like a very high number of PED, or high value of PED, excuse me. However, generally, we can actually draw specific demand curves which illustrate just a specific scenario. Like we can illustrate a demand curve that's just elastic or just inelastic. And so let's do that, and you see why that is the case. Let's say that this is my demand. Now, the general guide is look at the slope, and if it's flat, it would mean elastic. If it's steep, it would mean inelastic. Now, this is not always the case, and I'll prove it in a second. But this is your general guidance. So we see a flat demand curve, and we can say, oh, well, this demand curve will probably be elastic. Now, to be 100% sure, you have to imagine the demand curve as it extends and it reaches the q-axis. So you see, if we actually expand this, say this q-axis is going this way, and we expand this like that, the midpoint would be somewhere here. Now, when we were looking at just this bit, we weren't really seeing that. But if you imagine how this line can be expanded and where the midpoint would be, you would see that we are actually located in the elastic part of the demand curve. If on the other hand we would see something like this, which I'm trying to match the slope of this one, D1, and let's say this one, D2. I may not be doing a great job, but effectively what I'm trying to show you is this part over here. So let's say now I'm zooming on this blue rectangle. Just because this may seem flat, it does not mean that it is elastic. It will be inelastic because we are at this end of the demand curve. So always when you see demand curve, imagine how it can be expanded and which part of the demand curve you're seeing, because the price elasticity of demand changes along the demand curve. That's very important. It's not constant and it's not depending on the slope. Do not confuse the slope of the demand curve with the elasticity of price. Well, the demand elasticity of price. Price elasticity of demand. So having said that, we can derive several examples that kind of show us, if you want to draw a demand curve that we want to really put focus on the fact that it has a certain type of elasticity. So we're going to need actually five diagrams. I'm going to try to put them all together. 1, 2. 3, 4. Okay, and I'll put the fifth one over here. Quantity, price, quantity. Okay, so I'm gonna have a flat line like this. I'm gonna have a steep line like that. So this is D1, D2. Okay, I'm gonna have like a funky curve like this. D3. Then I'm gonna have a vertical line and a horizontal line. So this is D4 and this is D5. Okay, so generally, if you see diagrams and demand curves like these, you can automatically assume that this one is elastic. So PED is greater than 1. That PED, this is absolute value. Elastic because we are only seeing the elastic part of this demand curve. Over here, the price elasticity of demand would be equal to, actually, not will be equal, but it will be less than 1. So this is inelastic, simply because we are seeing this part of the demand curve that's closer to the Q-axis. But again, notice flat, steep, flat, steep. So flat generally means elastic, steep generally means inelastic. Now this one is a specific case where the price elasticity of demand would always be equal to 1. And this is called a hyperbolic parabola. You generally will not be asked this question, but a demand curve that follows this nature of a hyperbolic parabola would always have a price elasticity of demand of 1. Now, these two cases, however, they're the ones that are interesting. This one is the horizontal line. Price elasticity of demand would be equal to infinity. Notice, this is what I was telling you before. For that given price of P1, you're free to sell Q1 units, but you can also sell Q2 units, you can sell Q3 units, and so on. Effectively, at this price, it depends on the firm how many units they can produce. If they can produce 1 million units, they'll sell 1 million units. If they can produce 5 units, they'll sell 5 units. The limit is on the amount of units that the firm can produce. But at this price, the consumers will buy everything. And this will be an example of a perfect competition. And again, this is a topic for another lesson. And this one over here, should I use the red? Another extreme, the price elasticity of demand is equal to 0. That's a 0. There. Like that. And no matter what price we choose, P1, P2, we're always going to generate this Q1 quantity. So this is your life-saving medicine where a certain amount of quantity is needed by the market, and only that. The price is irrelevant. All right, guys. Well, this is it. This is a part 1 lesson to price elasticity of demand. There will be a part 2 where we're going to look at the determinants of demand, because often we don't really have values, like we don't have the specific numbers to calculate the PED. Yet by examining the kind of a product we're talking about, we can estimate what type of elasticity, price elasticity of demand this product will have. So this is coming up in part 2. If you like this video, please hit the like button. If you haven't, hit the dislike button. Let me know how I can change it. Please subscribe to the channel. This will help, and I hope to see you again. Take care.